Hello, my name is Graham Wood. Today we're going to be exploring my MIS665 data analytics project. And we're going to be exploring how to predict great movies. What makes a movie great? That's kind of the question that we're asking. And we're going to look at all the factors that go into movies to try to figure out if we can predict whether a movie is going to be good or bad. And we're going to be using an IMDb database with a bunch of data related to movies to help so that we can analyze and figure out, what predictors will make a movie have a higher IMDb score on average. So we're going to do this through silver data analytics methods. We're going to be using machine learning. We're going to be using algorithms like sklearn, random forest, regression analysis, and classification analysis, as well as some business analytics and some general business or data processing. So the process is, first off, we need to acquire the data. And then we need to process the data and perform analysis on it so we can gain key insights into what we're actually looking at and what we have to work with. Once we do that, we should be able to identify areas that the data needs to be cleaned. And so we will get rid of any null data or data that doesn't quite fit into the data set. And then we'll prepare the data. So we'll organize the data in certain ways so that we can use it to create analysis and that so that it will fit into algorithms. And then we will create insights into that data, doing some modeling. And then we'll create the algorithms and put the data through the algorithms. And then we will analyze the results once they come through the other side and make conclusions on what makes a movie great. So the first step is to acquire data. So the data set was given to us through a source called Data World. Data could also be received through web scraping, but for this project we did not do that. So the data is loaded into Python Jupyter Notebook, and then we take a look at the data. So here you can see we checked what data is null. So obviously null data is not something that we want. And so we have two methods to solve this. We can fill in that null data with averages for data around it, or we can drop all the rows that have a null column in it, or we can drop columns as a whole. So we did all of those for the project. So obviously you can see at the top, we're filling columns with null data with the averages for that data. And down below, you can see us creating dummy variables and dropping columns that are not needed, columns that we've decided either aren't relevant or would throw off the data. And then we need to clean and prepare the data. So this is an example of preparing the data. So we're making categorical variables for the score so that it can be processed by an algorithm a little bit better. So obviously we're grouping the IMDb scores. It's kind of like an okay, good, great, amazing range here. And then we want to create insights into our data. So this we can just use making graphs and doing some business analysis to determine some general insights into the data. These insights aren't necessarily proof of anything, but they help guide us into the direction of what we want to explore, things that might end up being these factors that influence the score of a movie. So obviously on the left, we can see that the duration and the IMDb score appear to be closely related. On the right, we see that budget and IMDb score is not related very much at all. And then we want to create the algorithms we're going to use. So to do that, we need to select which variables we want to put into the algorithm. And that can be done through the business analytics we've done before and gaining insights into the data. And we want to feed that data into the algorithm and then analyze the results once it comes out. So we want to see the variance of these algorithms and the mean square error. And since we have a lot of algorithms to work with, we can kind of compare all those algorithms, decide which one is the best, and then we can deploy that algorithm and analyze the results of it. So we want to use the algorithm with the highest R squares, which means it's the most accurate, and we want as small as variance as possible. So the results of it, we get to see what makes a movie great. So this is an example of one of the algorithms we use. So you can see that the duration was very high on this algorithm. Number of users for review, budget actually did end up correlating to the success of the movie. Other things that we analyze through other algorithms is that the actual biggest um, determinant of the success of a movie was the director of the movie. That hiring more popular directors based on the amount of likes they had on Facebook correspond the highest to the success of a movie. Other things like duration and ratings also played factors. And with something so complicated as movie prediction, you can't just point to one variable. Obviously, if you point to a director, they have bad movies. If you point to a long movie, it can also be bad. Um, but there are a lot of different variables that went into it. This data can be used to help predict movie producers to see what they need to put into their movies to make it have the highest chance of being successful. Obviously, no algorithm can tell you for sure how successful a movie's going to be, but hopefully, with this results, they can make a more educated decision on that.